What are Ethernet cables, and why do they matter? Ethernet cables are the physical wires that connect your devices to your network. One end plugs into your computer, gaming console, or smart TV, while the other end goes into your router, switch, or modem. These cables are what actually carry your internet data back and forth, and unlike Wi-Fi, they provide a direct, stable connection that doesn't care about walls, interference, or how many people are streaming in the next room. The cables we're talking about are called twisted pair cables. Inside the outer plastic jacket, you'll find 8 individual wires arranged in 4 pairs. These wires are literally twisted around each other, and this isn't just for looks. The twisting prevents electromagnetic interference and something called crosstalk, which is when signals from one wire leak into another wire and cause errors. Think of it like trying to have a conversation in a crowded room. The twisting helps keep each wire's conversation private. Now, there are 2 main types of these cables. Unshielded twisted pair, or UTP, is what most people use. It's just the twisted wires inside a plastic jacket. Nothing fancy, but it works perfectly fine for home and office use. Then there's shielded twisted pair, or STP, which has an extra foil wrapper around the wires. This shielding adds another layer of protection against interference, but it's mainly used in industrial settings where there's a lot of electrical noise from machinery. For your home network, you almost certainly have UTP cables, and that's perfectly adequate. Cable categories explained. The speed ratings. Every Ethernet cable has a category rating, and you'll see this written as Cat 5, Cat 6, Cat 7, and so on. The Cat stands for category, and these numbers represent different versions of the Ethernet standard. Each category has specific performance specifications, mainly focusing on maximum speed and bandwidth. Higher numbers generally mean better performance, but there's more to it than just picking the biggest number. Let's start with Cat 5. This is the original standard that most people think of when they hear Ethernet cable. A true Cat 5 cable is rated for speeds up to 100 megabits per second at a maximum distance of 100 meters, with a bandwidth of 100 megahertz. Here's the thing though, Cat 5 is basically obsolete. You probably can't even buy a genuine Cat 5 cable anymore because it's simply too slow for modern networks. If you have any Cat 5 cables lying around from the early 2000s, it's time to replace them. Next up is Cat 5e, which stands for Category 5 Enhanced. This is extremely common and is probably what most people have in their homes right now. Cat 5e bumps the speed rating up to 1 gigabit per second, still at 100 meters distance, with the same 100 megahertz bandwidth. The improvement comes from better internal construction. The wire pairs are twisted more tightly, and the overall design reduces interference more effectively. Cat 5e also uses all 4 wire pairs for data transmission, whereas Cat 5 only required 2 pairs. This is why Cat 5e can handle 10 times the speed. One important thing to understand, these ratings are minimum specifications. A high-quality Cat 5 cable might actually be capable of gigabit speeds, even though it's only officially rated for 100 megabits. The category rating tells you what the cable is guaranteed to do, not necessarily its maximum capability. The modern standards, Cat 6 and Cat 6a. Cat 6 is where things get interesting for anyone building a serious home network. Category 6 cables are rated for 10 gigabit speeds, but there's a catch. They can only maintain those speeds up to 55 meters. Beyond that distance, the speed drops back down to 1 gigabit. Cat 6 also has a bandwidth of 250 megahertz, which is a significant jump from the 100 megahertz of Cat 5e. This higher bandwidth means the cable can reliably transmit data across a wider range of frequencies, which translates directly to faster speeds. The internal construction of Cat 6 is more sophisticated. The wire pairs are wound even tighter than Cat 5e, and many Cat 6 cables include a plastic core running down the center. This core physically separates the 4 wire pairs from each other, which further reduces crosstalk and interference. Some manufacturers also add more robust outer jackets to prevent damage. All of these improvements cost more to produce, which is why Cat 6 cables are typically more expensive than Cat 5e. If you're buying cables today and you're not sure what to get, Cat 6 is probably your best choice. It's not drastically more expensive than Cat 5e, and it gives you room to grow as network speeds increase. This is especially important if you're installing cables in walls or ceilings, where replacing them later would be difficult or expensive. For permanent installations like wiring a house, you should absolutely use Cat 6 as your minimum standard. Then there's Cat 6a, which stands for Category 6 Augmented. This cable maintains 10 gigabit speeds across the full 100 meter distance, not just 55 meters meters. It also doubles the bandwidth to 500 MHz. The construction specs are even stricter than Cat6, with improved shielding and better separation between wire pairs. If you're actually running a 10 gigabit network and need cables longer than 55 meters, Cat6a is what you need. For shorter runs, Cat6 will work fine. Cat7, Cat8, and beyond. The extreme performance cables. Category 7 cables take things to another level. Cat7 is also rated for 10 gigabit speeds at 100 meters, but it has a bandwidth of 600 MHz. More importantly, Cat7 has the strictest specifications for reducing interference. These cables require shielding around each individual wire pair, plus an additional shield around all 4 pairs together. This double shielding makes Cat7 cables noticeably thicker and less flexible than Cat6 or Cat5e. The real benefit of Cat7 isn't necessarily speed, since it has the same 10 gigabit rating as Cat6a. The benefit is reliability and future-proofing. With all that shielding, Cat7 cables can handle more electromagnetic interference and crosstalk than any other cable type. If you had a network switch capable of speeds faster than 10 gigabit, a Cat7 cable would probably be able to handle it. For most people, Cat7 is complete overkill. It's designed for permanent installations where you want absolute maximum performance, and you never want to worry about replacing the cable. Then we have Category 8, which is the current top of the line. Cat8 is a shielded twisted pair cable, rated for absolutely ridiculous speeds, 40 gigabits per second. However, there's a significant limitation. Cat8 can only maintain those speeds up to 30 meters. Beyond that distance, performance drops. Cat8 is primarily designed for data centers and server rooms where devices are relatively close together, but need extremely high bandwidth. The cable is thick, stiff, and expensive. For home use, Cat8 is honestly pointless unless you just want bragging rights. It's worth noting that most consumer devices can't even use these higher speeds. Your typical computer network card supports 1 gigabit, maybe 2.5 gigabit if it's recent. Very few consumer devices have 10 gigabit network cards, and practically nothing outside of enterprise equipment supports 40 gigabit Ethernet. Straight cables versus crossover cables. Understanding wiring standards. When you're making your own Ethernet cables or just trying to understand how they work, you need to know about wiring standards. There are 2 main standards called 568A and 568B, and these determine the order in which the colored wires are arranged inside the cable connector. The 568A standard arranges the wires in this order: white-green, green, white-orange, blue, white-blue, orange, white-brown, brown. The 568B standard uses this order: white-orange, orange, white-green, blue, white-blue, green, white-brown, brown. Notice that the only difference between these two standards is that the green wires and orange wires are swapped. Both standards work exactly the same way. There's no performance difference whatsoever. In the United States, most people use the 568B standard, but either one is perfectly fine as long as you're consistent. A straight cable, also called a patch cable, is wired using the same standard on both ends. So both ends use 568A or both ends use 568B. This is the type of cable you use for almost everything in a home network. Straight cables connect computers to routers, computers to switches, or any device to a network port in the wall. Basically, if you're connecting 2 different types of devices together, you use a straight cable. This accounts for probably 99% of all Ethernet cable usage. A crossover cable is different. It has one end wired with 568A and the other end wired with 568B. Crossover cables are used to connect 2 similar devices directly to each other without a switch or hub in between. For example, if you wanted to connect 2 computers directly together to transfer files, you would use a crossover cable. You could also use crossover cables to connect 2 switches together or 2 hubs together. However, most modern network equipment has a feature called Auto MDI that automatically detects what type of cable you're using and adjusts accordingly, which means crossover cables are becoming increasingly rare. Real-world performance, what actually matters. Here's where theory meets reality, and the results might surprise you. In real-world testing with actual hardware, the difference between cable categories is often much smaller than you'd expect, especially at shorter distances. When testing Cat5e, Cat6, Cat7, and even Cat8 cables at lengths under 10 feet with 10 gigabit equipment, all of them performed almost identically. Every cable delivered speeds around 9.7 to 9.8 gigabits per second, which is essentially the full capacity of a 10 gigabit connection. Even more surprising, a genuine old Cat5 cable, which is only officially rated for 100 megabits per second, was able to achieve full full 10 gigabit speeds at very short distances. This seems impossible based on the specifications, but it demonstrates an important point. The category ratings are minimum guarantees, not maximum limits. A well-made Cat5 cable can exceed its rating significantly if the distance is short enough. Obviously, you shouldn't rely on this for anything important, but it shows that cable length is absolutely critical to performance. This is why the specifications always include a distance rating. Cat6 can do 10 gigabit at 55 meters, but Cat6a can do it at 100 meters. As cable length increases, signal quality degrades. The electrons traveling through the copper wire encounter resistance, and the twisted pairs start picking up more interference. Higher category cables have better construction that fights these problems, which is why they maintain performance over longer distances. For the average home user with cable runs under 50 feet, Cat5e is honestly sufficient for gigabit internet, which is the fastest residential service available in most places. Cat6 gives you headroom for future upgrades without costing much more. Cat7 and Cat8 are really only necessary if you're running a 10 gigabit network or installing cables in difficult to access locations where you want maximum future proofing. Choosing the right cable, practical recommendations. So which cable should you actually buy? The answer depends on your specific situation. If you're just connecting your laptop to your router with a short cable that sits on your desk, Cat5e is perfectly fine and will save you money. Your laptop almost certainly has a 1 gigabit network card anyway, so a higher category cable won't make any difference. For general purpose, cables that you might replace easily, Cat5e handles everything most people need. If you're installing cables inside walls, running them through ceilings, or burying them underground where replacement would be expensive and difficult, go with Cat6 as your absolute minimum. Better yet, use Cat6a if your budget allows. Yes, it costs more upfront, but you're essentially buying insurance against future obsolescence. When 10 gigabit internet becomes common in homes, you'll be glad you spent the extra money now, rather than having to rip out walls later. For extreme future-proofing and permanent installations, Cat7 makes sense if you can afford it, and don't mind working with thicker, stiffer cables. The extra shielding means your network will remain reliable even as speeds increase beyond what we can imagine today. Cat8 is really only worthwhile for data centers or specialized applications where you absolutely need 40 gigabit speeds over short distances. For home use, it's expensive overkill that your equipment can't even utilize. One final consideration is interference. If you're running cables near electrical wiring, fluorescent lights, or other sources of electromagnetic noise, the extra shielding in Cat6a or Cat7 can make a real difference in maintaining stable connections. Similarly, if you're bundling dozens of Ethernet cables together in the same conduit, higher category cables with better crosstalk protection will perform more reliably. But for typical home installations with a few cables, interference is rarely a practical concern with any modern cable category. Now go check out the breakdown of every HDMI version to complete your cable knowledge.